Problem sheet 3, question 2. At a chicken shop, the deep fat fryer can be described as a Markovian queue. Chicken pieces are put in the fryer at a rate of lambda per time unit. There is room for only 3 pieces of chicken in the fryer, and no new chicken orders are taken when the fryer is full. When a chicken piece is in the fryer alone, it completes frying at a rate of mu. When there are 2 pieces of chicken in the fryer, they cook at a rate of mu over 3. And when there are 3 pieces of chicken in the fryer, they cook at a rate mu over 4. Find the steady state probabilities in terms of lambda and mu, and then find the expected number of pieces of chicken in the fryer when lambda is equal to 5 and mu is equal to 9. So the deep fat fryer can be described as a Markovian queue, and it's kind of a processor sharing queue, where the more pieces of chicken there are in the fryer, the slower they cook. So this is a finite capacity queue, so in order to find the steady state probabilities of lambda and mu, we will look at the Markov chain representation of this queue. So if the states are the number of pieces of chicken in the deep fat fryer, the states can be described as either 0 pieces of chicken in the fryer, 1 piece of chicken in the fryer, 2 pieces of chicken in the fryer, or 3 pieces of chicken in the fryer. That indicates that the fryer is full and no new chicken orders are taken. They are put in the fryer at a rate lambda per time unit, so they increase up the states with a rate lambda. When there is 1 piece of chicken in the fryer alone, it fries at a rate of mu. When there are 2 pieces of chicken in the fryer, they cook at a rate mu over 3, but there are 2 pieces of chicken, so the rate at which this state goes down is going to be 2 over 3 mu. And when there are 3 pieces of chicken in the fryer, they cook at a rate of mu over 4, and there are 3 pieces, so this reduces the rate 3 over 4 mu. So to find the steady state probabilities, we want to find a vector pi, which is the probability of there being 0 chicken in the fryer, the probability of there being 1 chicken in the fryer, probability there being 2 chicken in the fryer, and the probability there being 3 chicken in the fryer. We want to find a pi that solves pi q is equal to 0, where q is the transition rate matrix. So we can write q as So we want to find a vector pi that solves pi q is equal to 0, and remembering that the sum of the probabilities in pi equals to 1. So expanding that out gives us So we get this system. We'll be doing a lot of manipulation to try and find which values of pi 0, pi 1, pi 2 and pi 3 fit and solve this system. So let's label the equations to help us with our manipulations. A useful tactic, as always, is to put all the unknowns in terms of just one of the unknowns. So let's try and put everything in terms of pi 0. So we can take equation 1 and rearrange this to get pi 1 in terms of pi 0 by dividing through by mu. Then if we take equation 2, we can make the substitution that pi 1 is equal to lambda over mu pi 0 and rearrange to get pi 2 in terms of pi 0. Expand this out. And simplify by taking away lambda pi 0 from both sides. and dividing through by 2/3 mu. Finally, we can look at equation 4 to get pi 3 in terms of pi 2, and we now have pi 2 in terms of pi 0, so that gives us pi 3 in terms of pi 0. And divide through by 3/4 mu. Now that we have pi 1, pi 2 and pi 3 all in terms of pi 0, we can take our final equation, which was the equation that all the probabilities sum to 1, make those substitutions, factor out a pi 0, and then divide through by the scalar multiple there to get pi 0 is equal to 1 divided by Now, as we have all the other probabilities in terms of pi 0, we can make those multiplications and find the state probabilities as asked for. The final part of the question is asking, what is the expected number of pieces of chicken in the fryer when lambda is equal to 5 and mu is equal to 9? So let's just recap everything we've found so far. So these are the relations we've just found. When lambda is equal to 5 and mu is equal to 9, we can substitute in and we get that pi 0 is equal to 1458 over 3443. And then we can make the same substitutions in for all the others, where we get pi 1 is equal to 810 over 3443. Pi 2 is equal to 675 over 3443, and pi 3 is equal to 500 over 3443. We want the expected number of pieces of chicken. The expected number in a queuing system is usually denoted by L, and we can find out the expected number by summing up the state multiplied by the probability of that state between all the possible states. So in this case we would have 0 times by pi 0 plus 2 times by pi 2 plus 3 times by pi 3, which gives us a value of around about 1.063 pieces of chicken in the fryer.